So we have been talking a bit about color rendering and the different typology of light sources with dynamic whites and dynamic colors and all the different versions, and what is a CRI and what is a TM3015, and different methods to measure the color rendering. But something that is also very important to understand is the color space. And the color space, it's a concept that helps to define or calibrate the kind of data that we are using to measure the color. So the color space is basically a threshold, if you want to call it like that, or a world or a space where you can use different parameters to represent different performances for your light sources. And the color space, it's related to color, not related to lighting specifically. So we have in lighting some color spaces that are working really, really good for lighting. But you will find many other color spaces that are related to the digital world or are related to paint or something else. Actually, a very, very common color space that everybody knows is the CMYK, and that's used for printing. So probably you heard all these problems with the calibration of a printing machine and the computer that you have, that the graphic designer has at home, and how to make the colors look the same when you are printing over paper and with the different inks and so on. So we have a similar problem, but luckily in lighting we have a standardized method. Still there are some differences and some color spaces, but more or less they are standardized, so we know where we are. More important even than the color space, which is something very related to how we calibrate the LEDs, the manufacturers, is for the users, the concept of color mixing applied to a controller. So normally in a controller or a console, a lighting console, you have the possibility of using RGB parameters. And this is how most of the LED fixtures work, because all of them use additive mixing and they are using red or green or blue LEDs, so the lighting consoles and the controllers adapt to that situation, especially after the pixel mapping came into the industry for media facades or for tours, and made a big difference on how to manage all this data coming from the light sources, because in pixel mapping, every single LED comes with red, green, and blue information, and all this amount of LED, all these signals, needs to be handled in a way that makes sense. But before that, the lighting consoles were using a different color space that was the CNY. And why the CNY? Especially the controllers we are talking about, in the controllers in the stage lighting industry. And why CNY? Because most of the moving heads in the market, even the static washes, long time ago, they were using a white light source that normally is a discharge lamp. Some moving heads, not a lot, were using also a tungsten light source, but most of them a discharge lamp, an MSR or HMI or different light sources, but all of them a discharge lamp that is a fixed white light source. Not dynamic, no possibility of using colors electronically, no additive mixing. So since it's a white light source, you need to use subtractive mixing. If you want to know more about that, you can see some of our videos for the different types of luminaires and how a moving head works and so on, and you will see how this works. And of course you have a lot of information on the internet. But basically, this type of mixing is basically filtering the light with physical filters and extracting specific colors out of it. So in terms of adding colors to generate a white, we do it the other way around. Most of the lighting consoles are used to this system, and they are all the profiles for the luminaires, all the encoders that you use to program your scenes are based on this concept, because the lighting consoles, of course, have some heritage for the older software versions. And only the modern consoles, it's now almost 15 years, even sometimes even more. Some of these consoles adapt the concepts from the CMY into the RGB. So now it's very common that in a lighting console you can switch between these two systems and first set in the profile of the console, okay, I'm using a fixture that is CMY based for the color mixing, or I'm using a fixture that is RGB based for my color mixing. And after doing that, you always have the chance in your encoders to have separate DMX channels for red, for green, for blue, or for cyan, magenta, and yellow. And of course, the percentages will work in a completely different way. So if you have a red channel, then 0% means no output, 100% means full output in red. When you're using a CMY system, and you're using a cyan channel, for example, then 100% is no cyan, and when you are decreasing it, then it goes to 0%, and then you get all the cyan, or other way around, depends on the console, sometimes it's the other way around. But what I'm trying to say is that in the CMY, instead of adding light, you are subtracting light out of white. So you start with white, everything is 0, and then you are adding, okay, if I mix cyan and magenta together, then I get a red. Okay, so another different way of controlling the colors is the HSI space. Not a space, we can call it more a method of mixing colors or playing with colors or controlling colors. And in that system, the H means hue, the S means saturation, and the I means intensity. So basically with the hue, you can change the color. So in the same values from 0 to 100%, you can go through the different colors. This is a red, a magenta, yellow, whatever. With the saturation channel, you can just decide, okay, how saturated this color is. So 100% in a red, in hue red, when you're using a saturation of 100%, you will have a very defined contrast saturate red. And if you go to saturation 0, or not 0, but 10% or something like that, then you will get a very, very desaturated red, but it's still red. And then the intensity is like the dimming, right? So the level of light output that you have. And combining these three, it's just a different way of working. You can get more or less the same behavior that you have with RGB and then you have with CMY. There's another color mode. Probably mode is the right word, which is the XYZ. And in this mode, you are basically playing with coordinates. So to understand this mode, it's necessary to understand as well what a color space is. And as I said before, color space is basically you are playing in a graphic space where you have different coordinates, which are the X, the Y, and the Z, and depending on which numbers you are using, then you get a result, a specific color or another. It's very important also to understand that in these coordinates, the number 1 is a fictional color. So if you have coordinates of 1, 0, 0, for example, that color does not exist because it's really in the borders, in the limits of the color space. But let's explain a bit more about the color space because that will help to understand the XYZ. So the most common color space in the lighting industry is the CIE color space. And initially, the CIE color space, it's sometimes called as 1931. This is an old system that we have to define how the colors behave. But the good thing, though, is that it's still a standard. So we have been using all these years the same color space, unlike in graphic environments or digital environments, and that's a great advantage because we know more or less what we can get out of it. And in this color space, you have the white more or less in the center. Of course, everything you want to know about the CIE 1931, you have tons of information in the internet, but as always, here in the Academy, we're trying to explain the basics of it. So in this case, you have the colors in different areas, and basically, this is interesting to define the paths from one color to another, right? And using these coordinates, you can select, okay, where you are in the color space. So doesn't matter what system you are using, and doesn't matter what emulation software you are using to reproduce how the lights will behave, or the kind of light sources that you are using. If you have a specific color coordinate, that's constant. That's a value that will stay there. And that's the great advantage of the coordinates, that you have a value that you can use in different systems, and it keeps constant. So it's not being modified depending on each console, which is something that does not happen here. Because of course, depending on the console, the weight, and depending on the light source, depending on the emulation software, the reproduction of a digital value will be different. So saying that I want a color that is 128 of red, 20 of green, and 50 of blue is not really telling to an installer or a rental company or a provider what color that lighting designer needs. Because that will work in a specific color space, and in the color space of lighting, we use coordinates to reflect that. Even when there is a way to translate in between modes, definitely between these three, it's very clear, and even with the coordinates you can do that, but the only systematic system or scientific system that we have to evaluate these is the coordinates. And that's why sometimes when you want to know the behavior of a specific fixture, you ask the manufacturer for the coordinates of the color, of this nanometer peak of wavelength, to know exactly, okay, how this color behaves in terms of calibration, what's exactly the wavelength of this red, and what's the coordinates in the CIE color space, so I know how to emulate it and how to mix them together through a special software. So one thing more that I need to say is that there is another system that is adding, which is the CIELUV, that is adding some extra things to this color space. Basically, it's making it wider, making it bigger, and allowing the user to make color paths that are more linear between colors. And in lighting, this means a lot. It's easier for the systems to translate this into a linear color path or a seamless color path when you use a system like that. And some consoles are prepared for that, and they need to do a lot of work in terms of color math and algorithm to get to that point, but this is a space, a more modern color space that is becoming a trend or a new way of generating colors for those users that are very, very interesting on having accuracy on how they reproduce the colors. So we discussed about, summing up, we discussed about different light sources, different types of light sources, dynamic or fixed. We discussed about color rendering and the different methods that we have for evaluating this color rendering in a light source or in a luminaire. And now we have discussed about color modes in different controllers, and also the color space that we use in lighting as a standard. And it's very important also, probably for a different video, that we'll discuss the relationships between the CIE color space and the color temperature and the black body curves and how that behaves, and saturation, non-saturation, different calibration colors, etc. So I hope you liked the video, and see you next time.